Alright, this is video 849, and I'm going to do number 3, which is to determine if the ratios are equal. So I have 33 times 22 over 22 is equal to 24 over 16, and I want to know, are those equal to one another? So the first thing I'd probably do is I'd come over here, right, and I would use the cross product. So I multiply 33 by 16 times 22 by 24. And when I do that, I end up with 528 is equal to 528. And sure enough, they check and they're equal to one another. That's one way to do it. If I have a calculator, it's a great way to do it. If I don't have a calculator, I may want to do it a different way. And I may take this 33 over 22 is equal to 24 over 16 and actually reduce my fractions. So I have 33 over 22, and I notice that 11 goes into both those numbers. So into both these numbers, right, I can put 11. So I'm going to divide both the top and the bottom by 11. So let's go ahead and grab a different color here, and I'm going to divide both of these. This is going to be kind of backwards, sorry, by 11, and that's going to give me 33 divided by 11 is equal to 3, and 22 divided by 11 is 2. And if I do the same thing on the other side and I look for what number goes into both 24 and 16, and the answer to that is 4, so I'll go ahead and divide everybody here by 4. That's going to give me 6, right, over 4, and I can actually simplify 6 over 4 all the way to 3 over 2. And, I see once again that 3 over 2 is equal to 3 over 2, and sure enough, those are equal to each other as well. So either way, I proved that they're equal to each other. The one thing I want you to be really clear is I can only do cross multiplication. So let's go ahead and write this up. So cross multiplication, like I did in the top there, when I did this times this times this times that, can only be done, that says E, that's an E, done. So funny, my hands, I just walked in the room, my hands are so cold I can't write. Can be done only when you have a, I'm going to run out of room, when you have let's go ahead and get a new screen here. Hold on. So let me get a new screen. Let me write this again. So cross multiplication. I want you to be very clear on this. Only when you have a single fraction equal to another single, that says single fraction. Okay, that's really, really important. So, for instance, oh my gosh, my hands are freezing. If I have something that looks like this, 4 minus x over 30 is equal to x minus 5 over 20. I have a single fraction equal to a single fraction, even though it looks kind of weird, right? That's all I have is two fractions here, 1, 2. So I can cross multiply. But if I have something that looks like this, 7 minus 3 over x is equal to 4 over x. Now, I don't have just a single fraction. Here's my fraction, here's my fraction. But I have this term right here, so I can't cross multiply. Okay? So that's the question I'm going to ask you, is when can I cross multiply? And the answer is when I have a single fraction over a single fraction. And then your extra credit, I'm going to give you an example and ask you if you can cross multiply or not, and why. Okay, so if I give you something that looks like this as your extra credit, you can't cross multiply because it's not a single fraction equal to a single fraction. But if I give you something that looks like this, you can, because it's a single fraction equal to a single fraction. So that's what you're going to get as your extra credit. And, you know, the problem that I ask you is going to be, when can I cross multiply? All right, that takes care of that first one. And now we have one more problem to do here. All right, all right, so now I'm going to do number 8, which is 30 over 125 is equal to n over 100. So in this case, right, I can use cross multiplication because I have a single fraction equal to a single fraction. So let's go ahead and do it first. I'm going to do it 2 different ways for you, so away I go. So I'm going to take cross multiply, so that, maybe I'll take a pen first, so that I have 30 times 120 times 100 is equal to 125 times n. That's going to give me, right, 3 times 1 is 3, and then I have 1, 2, 3 zeros, 1, 2, 3 zeros is equal to 125 times n. Now once again here, I hate it when it does that, I have multiplication here, so I'm going to go ahead between the 125 in the end, so to undo that multiplication, I'm going to divide everybody by 125, and that's going to give me n is equal to 24. All right, so, and that makes sense, right? So if you look at this here, right, 30 is significantly smaller than 125, and if you notice, 24 is significantly smaller than n. Okay, so that makes sense that that would be what I would get. All right, and then if I wanted to do it a different way, I might go ahead and take this 30 over 125, if I didn't have a calculator on me, is equal to n over 100, and say, okay, fine. 5 goes into 30, so I'm going to come over here, and once again, this is going to end up backwards. I'm going to divide both the top and the bottom by, by 5, and that's going to give me 6 over, and then 125 divided by 5 is 25, and I end up with then when I cross multiply, right, I'm going to actually, here, you know what, let's write that over on this side, is equal to 6 over 25. And now, right, I have my single fraction equal to a single fraction, right? I just wrote this in simplified form. And I'm going to get, over here, this is going to give me 25n is equal to 6 times 100. And then I can divide by both sides by 25. And I know that 25 goes into 25 once, and it goes into that 100 4 times, right? 4 quarters in a dollar, and 6 times 4 gives me 24. So that's another way I can go about doing it. Okay? All right, so in this particular problem, I need to ask you a question, right? So I think the question that I will ask you for this one is, you know, oh, here it is. I thought of it now. So in this particular case, when I'm doing this one, right, so if in the fraction that I have, if the numerator is smaller than the denominator, then when I solve for n, right, if it's in the numerator, it still must be smaller than the denominator, right? So the ratio, quick check to see if our number is correct, is to say, hey, 30 is way smaller than 125, so my n is going to have to be significantly smaller than 100, right? So that's a quick check, and that's what I will ask you. I will ask you, how do you do a quick check on your answer to make sure that it makes sense? And you'll say, if the number in the numerator is close to the number in the denominator in the fraction, then it has to be, when you solve for n over on this side, if it's a long way, if the numerator and the denominator are a long way apart in the fraction, then it has to be also in the one where I'm solving. All right, that's it, guys. We're done.